So now we're going to move to our next speaker, and it's going to be Joris van den Bossche from Voltron Data GeoPandas. And he's going to tell us about the GeoParquet, which is something that Javier mentioned just now. A columnar format for geospatial vector data using Apache Parquet. So over to you, Joris.
Yeah. Can you hear me?
Yes, we can hear you.
And do you see my screen?
Yes, we can, yeah.
Because I don't see it myself, whether you see it. Okay, so that's great. So I'm Joris van den Bossche. I'm working at Voltron Data on the Apache Arrow project. But for the geospatial part, I'm also one of the maintainers of GeoPandas. So for time, I'm going to skip this and get to the actual topic about Apache Parquet. So to know what GeoParquet is, we need to know what Apache Parquet, the file format, is. I pasted here the explanation from their own website, and let's go through it part by part. So to start, it's maybe not super clear, I'm highlighting something, but it's an open source file format, so it's an open specification, and a language agnostic file format. So there are implementations in multiple languages. In Apache Arrow, on which I'm working, we have a C++ implementation with Python and R bindings, but there are also Java implementation, there is a Rust implementation. It's a column-oriented file format. Maybe also to mention it's a binary file format, and column-oriented, meaning that so the data are stored by column, or at least by chunks of a column, and are therefore also well suited for heavy analytical workflows. It has some very advanced data compression and encoding features, with the result that it can produce very small files, which can be beneficial to reduce I/O and data transfer. But still efficient to read those data. It also handles complex data, so it has support for various data types, but not only the standard data types, but also nested data types. I think lists, maps, structs. So if you have a nested JSON structure, that's something you could also convert and store in Parquet data. In summary, it's a widely used file format. It's originally from the Hadoop ecosystem, but nowadays it's used outside of that as well. It's widely used to store large amounts of data. I think the typical data lakes, typically for as the starting data for analytical workflows. And it's also a format that is well suited for the cloud. So that's where GeoParquet comes into the picture. We have a useful and widely used file format for tabular data. Vector data often comes in a tabular format, so we can match those two and try to store geospatial data in Parquet. And that's what the goal is of GeoParquet. So we want to standardize how we store such geospatial data in Parquet to ensure that the different tools that would use Parquet, that we ensure that there is interoperability between the different packages, cloud data systems, and that we can also push such a column-oriented file format into the geospatial world. In the end, GeoParquet is just a specification how we are going to store geospatial data in Parquet files. Parquet is an existing file format, an existing specification. So what our own GeoParquet specification adds on top of that is we specify how we are going to store the geometry data, which data type to use, currently we store the data as well-known binary, so as a binary column. But in the future, we can expand on that. And in addition, we store a bunch of metadata. I will directly show an example of that. Some of the features of GeoParquet, the first few are related to the actual, to the geospatial part. So in the metadata we store, so we store information about spatial reference systems. So you can have multiple spatial reference systems that can be used. So it's not limited to a single coordinate reference system. You can have multiple geometric columns. We can specify whether you have planar or spherical coordinates. And there are some additional features. I already mentioned them before, I think, that are more specific to Parquet. So you have very good compression, good at really heavy analytical processing. And Parquet files are often used in partition data sets, so where you have many Parquet files in a certain layout. It can also be helpful for when reading subset of the data. So some things that make Parquet very suitable for such analytical workflows. So you can have partitioning, but in addition, Parquet file format has a lot of statistics at different levels, which make it very efficient to read only part of the data. That's for standard columns. That isn't yet working for geospatial columns, but that's something we want to do in the future. And there is also a talk, I think, just next to me. Here is a small example of how the metadata looks like. So for a certain column in the file, we store a bunch of metadata, so about the bounding box, the coordinate reference system, which encoding is used, the number of geometry types. I'll go a bit quickly. So I'm personally myself already using GeoParquet, or at least Parquet, for a while in GeoPandas. Afterwards, there was also an initiative started in the OGC repo. So with, amongst others, Chris Holmes and Tom Augsburger worked on initial version. But recently, with some help from a lot of people, so I listed here some of the project and companies involved. We released an initial release last month, and yesterday a second release with some additional features. But very important to note is that this is work in progress, so feedback is very welcome. Some future work that we want to do on this is that, expand the support for the format so that more tools are be able to work with it. GDAL in the master branch, there is actually already an implementation which will come in, so the next version of GDAL. There are some Python and R tools that I already mentioned before, but there are also some other talks after me that will tell some more about other tools or software systems that start to support this format. We certainly want to work on spatial indexing. Another talk is coming. There is an option to go beyond the well-known binary to have more efficient storage of the vector geometries using the GeoArrow specification. And of course, we need to stabilize the specification. Maybe just as a small last part, so very small benchmark, just to give you some idea. Every benchmark is flawed, so you can do this in many ways. I use Python here, so you get a lot of overhead from using Python, so it takes some caution with those numbers, but small comparison of the example data set that is linked from the README from the GeoParquet repo. So it's a polygon data set. So there's a small comparison of the file size compared to GeoPackage. I just compared to GeoPackage here. So you see that GeoParquet gives a much smaller file, which can also be read faster. Now, again, this is using Python, so you have the the overhead from the conversion from GDAL to Python in case of GeoPackage. While for GeoParquet, I'm directly using the Arrow project that will efficiently read the Parquet format without going through the row-oriented internals of GDAL. And especially if you select a single column, you see even a bigger difference, and that's where the column-oriented nature of Parquet especially shines. Voilà. That's my presentation.
Okay, thank you. Thank you very much, Joris, for this presentation. So in the meantime, Joris, while we have you there, when you converted from GeoPackage to GeoParquet, did you manage to preserve everything, or did you actually miss some of the features, some information?
Yeah, for this specific data set, I'm not super aware of possible limitations regarding data types for GeoPackage, but the data set included some strings, some integers, and a geometry column, and that's features that both support. So in this case, both files are equivalent.
Yeah, it was a very impressive benchmark.